Okay, this is part 2 of more patterns and sequences, and we're starting with objective 1. Work fluently between sequences in the appropriate recursive and explicit formulas. So we talked about finite and infinite sequences. Finite means it ends. Infinite means it goes on and it doesn't end. So let's look at this over here. This is talking about the term number. And this 4 is telling us there are 4 terms in the sequence. And the sequence right here, k equals 1, that's telling us that it starts with the first term. Okay, so the sequence is actually starting with the first term. It's not starting with the 5th term or the 4th term. It's starting with the first term. And you can see that here as well when we look at the infinite side. This is talking about the term number. This infinite sign means that it's going on and on and on. It doesn't end. And the sequence starts with the first term. So let's look at writing the explicit formula for this finite sequence. We have a sub k is equal to the first term, which is 1, plus how do we get from here to here? We are adding 3, and we add 3, and so on. So our common difference is going to be 3 here. So that's what we put in this blank. 3 times k minus 1. You can replace the k with n to make it much simpler, because that's what we've been using anyway. Now let's look at the recursive. Recursive, again, means we're building upon the previous number, which is like our ladder. So we state the first term, which is 1, and we take the previous term, and then we add the common difference, which is 3. Let's look at the infinite sequence. Let's look at our explicit formula. We have our first term is 3 plus our common ratio, which here our common difference, we're adding 4 each time. So our common difference will be 4 here. So we're going to put 4 times the previous term number. Recursive, state the first term. Then we take the previous term and we add that to our common difference, which is 4. Okay. So again, with the explicit formula, we would be putting the term number. In the recursive formula, we're taking the previous term. So this term number would be like the first term, the second. So for the second term, you would be writing 2. Here, if we say the second term, we're talking about 4, not 2, because the second term is 4. Okay. All right. Let's do some examples. Here we have g of n is equal to, we have a series here. So if n is equal to 1, then g of n will be 4. If n is greater than 1 and a whole number, then we're going to use this formula. So let's look at finding 4 of these terms. G of 1. So that means n is equal to 1, which means it's equal to 4. That one's pretty simple. Now we find g of 2. So when n is 2, that's greater than 1, I'm going to use this equation. So I'm going to do g times 2 minus 1 plus 3.2. So g of 1 plus 3.2, g of 1 is 4 plus 3.2, that gives me 7.2. So g of 2 is going to be 7.2. Now let's find g of 3. So I'm going to plug in 3 into the equation. 3 minus 1 plus 3.2. And this gives me g of 2 now. And now I look back and I say, okay, g of 2 we just found is 7.2. So 7.2 plus 3.2 gives me 10.4. So g of 3 is 10.4. Now let's find this last one, when n is 4. We're again using this equation. So I'm plugging in 4. So 4 minus 1 plus 3.2. 4 minus 1 is 3. So I just found that. And g of 3 is 10.4. And now we add the 3.2, and we find that g of 4 is 13.6. Let's do another example. When n is 1, it's equal to 14. And if it's bigger than 1, we're going to use this equation. So h of 1 is 14. Let's find h of 2. That gives me 28 over h of 2 minus 1. And we just found that h of 1 is 14. So I'm going to divide 28 by 14 to get 2. Now, h of 3. So 28 is over h of 3 minus 1 gives me 2. So that will be h of 2. That was our previous term. So what is our previous term that we just found? That would be 2. So 28 divided by 2 is 14. Now h of 4. We are dividing 28 by 4 minus 1 is 3. So h of 3. And h of 3 we just found was 14. So that gives us an answer of 2 again. So it's going to be going back and forth between 14 and 2. Let's look at this example. When n is 1, it will be equal to negative 6. When n is 2, it's equal to negative 4. And if it's greater than 2, we're going to use this equation. We're going to add the previous two terms. So f of 1 is going to be negative 6. F of 2 is negative 4. F of 3 is we're taking, let's see, 3 minus 2 plus f of 3 minus 1. That gives me f of 1 plus f of 2. F of 1 is negative 6. And then we add f of 2, which is negative 4. So that gives me negative 10. Adding two negatives gives us a negative. Now let's look at f of 4. So we plug 4 into our equation, and we clean this up a little bit, so that gives us f of 2 plus f of 3. F of 2 is negative 4, and we add f of 3, which we found was negative 10. So we add these together to get negative 14. We're going to find the explicit formula for g of n. So here it's saying that the first term is 2.7. And then we have this formula, f of n minus 1 times 6.1. So this right here is a geometric recursive formula. So we're going to use that to help us find the explicit formula. So this is the previous term, and we're multiplying it by the common ratio. Okay, so we have the first term and our common ratio to be able to write our explicit formula. The first term is 2.7, and we're multiplying that by the common ratio raised to the previous term, n minus 1. Okay. Now we have g of n is equal to negative 72 times 1/6 raised to the previous term, n minus 1. So here we have our first term, we have our ratio, common ratio. So this is an explicit geometric formula. Now we're going to find the recursive formula of that. So we need to state our first term, and we know that's negative 72. And then we have g of n minus 1 times, we need to find what the ratio is. So that would be 1/6 over here. Okay, now we have 2 times negative 3 to the n power. This is our first term. This is our common ratio. So again, this is a geometric explicit formula, and we're going to change this into a recursive formula using the previous term. So state the first term, which here is 2, and we multiply the previous term times the common ratio, which is negative 3. Now you're going to do some practice of explicit formulas. Okay. So again, use your first slide in this in the previous video from part 1, and seeing as you're on your slides anyway, this will be on this first slide of these notes. So use that to your advantage. You're using these examples to find explicit formulas, or you're stating if the students are correct with their formulas. Once you are done, you're going to check for understanding using the Google form. You'll click on it over here and see how you do. Okay, that will be the end of part 2. And